Hi children, in this video we will study the image formation of a convex mirror in the second case. Second case means here the object has been placed between P and infinity, pole and the far off distance called infinity. So we don't have any other points to keep the object because all the points are coming behind the non-reflecting side of the mirror. So we cannot keep between P and F, or we cannot keep at F at C. So these points are invalid in the case of a convex mirror because these all points are coming behind the mirror. We cannot place an object anywhere of this place, but we can place at two places. One at a far off distance in front of the convex reflecting side of a mirror, that is infinity, and secondly we can keep anywhere between P and infinity. Only these 2 points are coming into consideration in the case of a convex mirror. Okay, so in this particular case I kept an object between the principal pole and the far off distance called infinity. So in the ray diagram you will see look at the board to see the position of the object. This is my object. This is the object I placed between P and infinity. No other points to keep. Only here P and a far off distance infinity. All other points are coming other side, so we cannot keep. It is not possible to keep any object between P and F or at F at C, because these all points are on the other side, on not reflecting side of the mirror. So here an object is placed on this point. So this is the place where the object is kept. So AB is an object placed on the principal axis but between P and infinity of the convex mirror. So I consider a parallel ray coming out of the object AB. So AO is the incident ray that is parallel to the principal axis, that strikes the mirror at the point O, and it get reflected along another direction after reflection. This is ON is the reflected ray from the convex mirror. But this ray appears to be, this is according to the rule, this ray appears to be from the point called the principal focus. So this is the incident ray, this is the first reflected ray, but this ray appears to be coming from the point F on the other side of the mirror. So first incident ray and first reflected ray are ready, and I need to consider one more incident ray to find the image formation. So my second ray, that is pointing towards the point C of the mirror, a ray which is pointing towards the point C of the mirror. So this is the ray that is pointing towards this point, towards this point. So this is the ray which is pointing towards the point C. This is going to the point C. This is going towards the point C. So there is a small shift. I want to make it straight. So this is the point C. So this is the ray that is going towards the point C of the mirror. Okay, C of the mirror. So let me draw it properly. So this is the ray passing towards, so from here onwards I need to use dotted lines because this ray is not virtual, so I cannot use any virtual rays behind the behind the mirror. So this is my first ray, this is the reflected ray, this is my second ray passing towards the point C. That ray get reflected along the same path, but these two reflected rays appears to be meet at a point here. This is the point of intersection of two reflected rays. So here I can mark A dash, and to get the complete image I want to draw a perpendicular to the principal axis in downward direction. Okay, and this is the top. Let me show the top by using an arrow mark. So A dash, here it is B dash. So A dash, B dash is my image. That image is formed between P and F of the mirror. Clear? So let me conclude the image formation by using its characteristics, position, size and nature. What is the position of the image formed? Between P and F. Between P and F. And what is the size? Diminished. It is smaller than. This is my object. but this is the size of my image. So image is definitely smaller than the object. That is why I am writing dim here. Size is diminished. And nature, this is virtual one. It is not really existing. So what all images are getting on the other side, not reflecting side of the mirror, that will be virtual only. So I will never get a real image from the convex mirror. So virtual, and that is straight one or correct side up, or A dash is coming on above the principal axis, or definitely A dash B dash is a virtual and erect image of this object. Here the object has been placed between P and infinity. So this is a second case. We can keep an object anywhere between P and infinity. We will get an image always between P and F. So we will never get the image from the principal focus to that side, but we will always get it in between P and F of the mirror. That is always virtual, always erect one, and always diminished or smaller than the object placed, and the position is in between P and F. So these are the details of the image formed by a convex mirror. So with this we completed. So in page number 167 you can see two ray diagrams, and in a box you can see two positions of the object and two positions of the image, and the details about a convex mirror image formation. So there are only two cases. At first case we will keep an object anywhere between P and infinity, and in the second case we will first case at infinity, and the second case we will keep an object anywhere between P and infinity. So if it is at infinity, we will get an image at F of the convex mirror. If we place an object between P and F of the infinity of the mirror, we will get a virtual erect and dim image of the object in between P and F of the mirror, that is on the other side of the mirror, not on the same side as we keep the object, but opposite side, or in the back behind, or with in face with the non-reflecting side of the mirror. So these are the details about the image formation by convex mirror. So with this we completed all the rules, and now we completed all the rules as well as the two cases of convex mirror in detail with the ray diagram. Okay, so go through the textbook and study the cases, and in the notebook you can write the rules of image formation, 4 rules by using 4 different ray diagrams, and after that you can write 2 cases of a convex mirror by using 2 different ray diagrams, and you can conclude that in a box as you did in case of concave mirror. So you can copy the table number 10-2 into your notebook. Okay children, with this I conclude this class. Okay, thank you very much.